We did study in discrete mathematics, so why not to know some of the heroes of discrete mathematics? The people who are working in discrete mathematics, so especially those who are in the counting thing, so they are called combinatorists. And then we have like some related disciplines which uh, people are working in discrete mathematics. So like number theory, graph theory, and sometimes we include like geometry, or we make it mix with some other field like algebra or probability. But mainly, most important people are who are either combinatorists, are, I should say, those are the people who are proving theorems, problem solving, proving theorems. So in discrete mathematics, especially those who are doing research, so most of the time they are proving some interesting theorems. Like the theorems could be in any field of the mathematics, but over here, most of the time it's about counting or algorithms. Sometimes we deal with some more specific thing related to computer science. We call it theoretical computer science, which include like counting, algorithms, graphs, complexity analysis, computability analysis. But right now, I just want to introduce some of the big names, good names in discrete mathematics, who are like founder of discrete maths. So over here, the first picture that you see on the right top, so this is Leonhard Euler. So it is Swiss mathematician. Yeah, it gives a lot of things. Its contributions are numerous in mathematics. You must have known about Euler's identity and Euler's number. So in graphs, we have some good theorems like Königsberg problem, which is associated with Euler. And then there are so many other things like Eulerian cycle, Eulerian path, and many things. The next one is French mathematician Pierre de Fermat. He's he has numerous theorems, contributions in discrete mathematics. I will describe him further, especially one of his famous theorem. The third one over here you see, so this is Paul Erdős, one of the biggest name in combinatorics and number theory. He is quite recent one. So he's like one biggest name in mathematics for the last century. So Paul Erdős, he was quite famous for his interesting profile, interesting thoughts, interesting way of life. So uh, he was like a single man all his life, but he loved mathematics so much. Wherever he see like someone is working on mathematics, so he used to reach out there with his suitcase, and uh, he used to ask them, do you have got a good problem? Let's sit down and discuss." So all his life he was traveling all around the world. He did not have any formal job, so his all passion was about mathematics. So Paul Erdős was considered to be like one big guru of mathematics in his time. People love to work with him. So over here you see in network, it's called Erdős Collaboration Network. So over here is kind of graph. So Erdős is at the core of this graph, and people who work with Erdős directly, so they are linked to this central node. So those people who work directly with Erdős, those are, they associate themselves as Erdős1 because their link to Erdős is direct. So there's like uh, they are directly linked at a hop of one on the network. So they are called Erdős1. So someone who worked with Erdős1, so they become Erdős2. And someone who worked with Erdős2, they become Erdős3, and so on. Really, people don't count more than like Erdős4. And you can read about Erdős number on this given link. So there are 511 Erdős1 mathematicians. Those mathematicians who directly work and publish their work uh, with Erdős, who directly worked with Erdős and published their work. So they there are recorded 511. mathematicians. I would recommend to watch a beautiful documentary movie, A Portrait of Paul Erdős and His Number. It's available on YouTube. Pierre de Fermat, so he was 17th century French mathematician. He, in number theory especially, he gave many theorems. Fermat's little theorem is one famous thing. Mostly his work was on prime numbers. His work is used much in cryptography. Actually, why he, apart from his other contributions, so one interesting, I should say, incident happened which make him a much interesting guy. That is this Fermat's last theorem. Fermat's last theorem is like generalization of Pythagoras theorem. So this was an open problem for centuries and centuries. X raised per n plus y raised per n is equal to 0 raised per n. So the claim is there are no such x, y, z for n greater than equal to 3 for power 3. If it's like n is equal to 2, then it becomes just Pythagoras theorem. X squared plus y squared is equal to z squared. So interesting thing happened, like Fermat claimed like he has got the proof of this theorem. And he wrote down in his diary, at the margin of the diary, margin of the page in the diary, like, I have got the proof, but unfortunately, I do not have enough space to write down the proof over here. And after that, after like some time, he passed away. And when people found his diary, they were very curious. Oh, Fermat has got the proof, but what is the proof? Some people say like he was just mocking, he did not have proof, but some people say he was a clever guy. He must have got the proof. But what was the proof? It remained a mystery. So it took like more than 300 years. People were curious about the proof, and finally, Professor Andrew Wiles from University of Oxford in 1993, so he found the proof. And then another version he proved in 1994. It would be good to watch some videos on Fermat's, especially Fermat's last theorem. This is on YouTube. You can find a very interesting Fermat's last tango. It is quite interesting to watch. So about Euler we have discussed. So there is famous problem of Eulerian graph and 7 bridges of Königsberg. We are familiar with Euler's number. And Euler is like one of the mathematicians in the history who had numerous contribution in math. And if we go back in history, so Euclid, the Greek mathematician and philosopher, so his famous book, the elements, and his work on geometry. So all those geometrical shapes that we use in two-dimensional, like rectangles, circle, triangles, any other kind of quadrilateral polygons. So these are all called Euclidean geometry, Euclidean shapes. In the 2D space that we use, XY, which is also called Cartesian plane, is also called Euclidean plane. Again, he has numerous contributions. He's like one of the fathers of mathematics. One of his famous proof actually is theorem. So he has proven this thing like there are infinitely many primes. Primes do not have a pattern to like we can find what will be the next prime. But he has very simply proven like there are infinitely many primes. You can watch a video on this and you can prove by yourself quite easily. So next one is also very interesting, and it really like sparks the neurons of our mind. This guy was Srinivas Ramanujan. So he was quite humble guy in quite young age. In quite young age, he did a lot of contributions to number theory, especially in mathematics, and he died quite young. He did not have formal education in mathematics, so he had liberty to think independently and more uh, out of the box thinking. So he used to drop the constraints usually mathematicians put on the problem. So he could find some results which were quite eccentric, but later those results are proven to be very insightful. For example, his one of the claim is 1 plus 2 plus 3 plus 4 going up to infinity. Apparently, it's diverging sequence because we are adding all the positive numbers. But he has beautifully proven that this is equal to -1/12. This is something mind-blowing, but when we look at his proof, so it's like a high school mathematics proof. So I would recommend to watch this video about Ramanujan proofs of like arithmetic sequence. It's converted to -1/12, and he has numerous other this kind of proof in which he drops some of the rules which we put while proving something, and then he has got some amazing result. He is considered to be a man who knew infinity. And you can watch a beautiful documentary on Ramanujan, the man who knew infinity. One other living great mathematician, combinatorist, number theorist is Professor Bella Bosch in the University of Cambridge. Uh, at least we should know who is the current mathematician who is the greatest in our field. And then Terence Tao, this is perhaps most cherished mathematician who is living at the moment. So it is always good to know about the big names in our field. These are some of the texts, or some of the very beautiful texts in discrete mathematics. So these are good for learning. And Laszlo was book on discrete mathematics, graph theory, books by Wilson. So describe graph theory concepts very easily. Rosen book is like kind of encyclopedia for beginners in discrete mathematics. And this Taylor and Shu book, Introduction to Discrete Maths, give a good introduction to discrete mathematics. So we need to study mathematics. We need to build solid foundations, and we cannot proceed without solid foundation. Thank you very much for listening.